In the previous lesson, Sasha and Keoni constructed a parabola from its geometric definition. In this lesson, the goal is to make connections between geometry and algebra when a parabola is represented on a coordinate grid that has an x-axis and a y-axis. Sasha and Keoni begin by describing what they notice when the parabola is on a coordinate grid.
Now, the parabola you created in the first lesson was on a giant sheet of paper, but this one is on a coordinate grid. What do you notice now that the parabola is on the grid?
There
are points.
So it's like actually
They have the points labeled.
like numbered. Yeah, you can see where you are exactly. It's not just a random dot. It's 6 and 9.
When you said, Sasha, at the beginning that it gives you points, can you point to what you mean?
Oh, like, look, it's, oh gosh, draw.
That's
It's at 2, 1, or it's at all of those guys.
What do you think the 2, 1 means?
So here's the origin. If we're at 2, 1, it means we're 2 away from the origin, and then we go up 1.
Okay.
Sasha and Keoni have noticed something significant. On a coordinate grid, the points are numbered, like 2, 1 or 6, 9. A measuring system is built into the grid. As Keoni mentioned, the point 2, 1 is 2 units to the right of the origin and 1 unit up. This is different from lesson 1, when they made what Sasha called random points and used a ruler to measure distances. Watch for later in this lesson when Sasha asks for a ruler, but Keoni points out that they don't need one because of the coordinate grid. Next, Sasha and Keoni verify that 2 points that appear to be part of the parabola, 0, 0 and 2, 1, fit the geometric definition of a parabola.
So your goal is going to be to find all the points on this parabola, or to find a method for locating them. So we're going to start with ones that are already labeled or that you've already mentioned. So Keoni mentioned the origin. Can you point to that and label it again?
Yes. So the origin is right here.
2, 0.
Now, is the origin on the parabola? Can you use the definition of the parabola to justify or explain why it's on the parabola?
Yes, because it's in equal distance from the fixed point, the focus there, and from the directrix right there.
Okay. So now, can you look at those points, negative 2, 1 and 2, 1, and use the definition of a parabola to explain why those meet the definition, why they're on the parabola?
All right, so the 2, 1, right? This one?
Yeah.
Yeah? Okay.
Well, you can
I
start
know.
with either one, the 2, 1 or the negative 2, 1.
Go ahead.
Let's start with this one. Okay, so this one, it's 2 spaces this way, or 2 units from the focus, and 2 units from the directrix. So, yeah.
Sasha and Keoni have verified that the point 0, 0 and the point 2, 1 both fit the definition of a parabola. That is because both points are the same distance from the focus as they are from the directrix. In the next episode, Sasha and Keoni work with a more difficult point, and as a result, figure out how to use a tool that will be important for the rest of the lessons in this unit.